Hello and welcome to another fantastic day of math. Today we're going to be talking about how to solve inequalities. Today in class we graphed inequalities and we learned how to read them. And today we're going to learn how to solve them. And then as I said in class, solving inequalities is exactly the same process as solving one-step equations and two-step equations. So two-step is 8th grade, so we don't have to worry about that. Just a quick review. If you look up here, just a reminder that when you're looking at that inequality symbol, that larger side is the greater than side, the smaller side is the less than side. We also have equal signs for equations and not equal signs that we also will be using in math. All right, our learning target hasn't changed. We're still learning to solve one-step inequalities with one variable and learning how to graph the solutions to those inequalities on a number line. When they say one step, remember that one step just means one operation. Okay, just a reminder, remember we talked in class about how to remember those, which way the larger side goes. If you think of a crocodile's mouth, he's going to go eat the larger number. So if you look at this example, we have a 4 and a 6, and the crocodile wants to eat the 6 because it's more food in his belly. All right, if you look at your notes on page 17 is where we're going to be working. So go to your top of your notes and it says solving inequalities. To solve an inequality, follow the same steps that you use to solve an equation. Remember, an equation is the one with the equal sign. So to solve addition, and subtraction, inequalities, you're going to just simply use the inverse operation. So if we think inverse operation, this isn't on your notes, but just think the inverse of addition is subtraction. The inverse of subtraction is addition. And that undoes the constant that is paired with the variable. Remember, we want to get to 0 because we want to just have the variable by itself. The second step, or in this case, if you have multiplication or division, when you're solving multiplication, or division, inequalities, you use the same thing, inverse operation, or sometimes they give you fractions, and when they give you fractions, you have to use the multiplicative inverse. And that just simply means that if I give you 1/2, you're going to multiply by 2/1. That's all that you're doing, and that's so we get a coefficient of 1. So that's the identity property. So that's all we're doing. Same thing that we did when we solved one-step equations. We're using the inverse operation. So if it's an addition problem, we use subtraction. If it's subtraction problem, we use addition. If it's multiplication and it's just a whole number, then we can divide. If it's division, then we multiply by that number. Remember though, if you're multiplying by or dividing by a negative number, you have to multiply by that same negative number. Okay, the only exception, the only difference between equations and inequalities is this step right here. If you multiply or divide by a negative number, then you must flip the direction of the inequality sign. So what I mean, you don't have to write this in your notes, but you can if you want to. So if I have negative 3x equals 9, and I solve, oops, sorry, let me make that less than or equal to 9, because we're doing inequalities. I have to divide by a negative 3 to get a positive 1 on this side. Those cancel, and whatever I do on this side, I have to do also on the right. 9 divided by -3 is a -3, but my sign here is going to be switched. It's going to change direction. So instead of less than or equal to, it is now greater than or equal to. That's all we're saying. If you multiply or divide by a negative number, then you flip the direction of your sign. That's it. That's the only difference between solving an inequality and solving an equation. And don't forget at the end to check your answer or check your solution by plugging in any number that makes the inequality true to see if the solution works. So if we go back to our solution on the previous problem, we had 3x is less than or equal to 9. When we divided by a -3, divided by a -3, change the direction of our symbol. These canceled out, so we're left with just x, and this was a -3. So I have to think of a number that is x is greater than or equal to -3. So a number that I like that is greater than -3, that's an easy problem to multiply by, is always 0. Anytime you can plug 0 in and make this true, if I plug this in, is 0 greater than or equal to -3? 0 is bigger than -3. So I can plug it into my original equation for x and then see if it works. 3 times anything times 0 is just 0, multiplicative property of 0. So then it's asking, is 0 less than 9? Yeah, 0 is less than 9. So my answer works. So you have to know, this is my actual solution, but you have to be able to plug in something that makes it true to check your answer. That's what we're saying here for the check step. So let's look at some examples. There are 4 examples down at the bottom of your page. As we did with equations, we're also going to separate our problem by drawing a line. So we have 2 sides. We have the side with the variable and the side with the constant. In this case, I have to get rid of this -6. How do I get rid of a -6? I'm going to use the opposite, which is a +6. Whatever I do to that side, I have to do to this side. -6 and +6 cancel, and I'm left with just y. My symbol is not an equal sign. Be careful. Biggest mistake everybody makes is they write an equal sign instead of their inequality symbol. And then we add on this side. 12 plus 6 is 18. So this is my solution. It says that, and if I graph it, here's my 18, 17, 16, 19, and 20. It's equal to, so think about our lesson today, we're going to have a solid circle. Y is smaller than 18, so that means I'm going to color it to the less than side, which is to the left. And then to check my answer, I need to think of a number that's smaller than 18. 0 works. So since 0 is less than 18, I'm going to use 0. So -6 plus 0 is less than 12. Well, anything plus 0 is just itself. That's the identity property. So then I ask myself, is -6 smaller than 12? Sure is, so I know that my check step works. Okay, so let's look at our next example. So in this one, don't forget, get rid of your double signs. So I rewrite this as r plus 2 is greater than -5. Draw your line to separate your problem. Now, I'm going to get rid of this because that's the side with the variable. To undo a +2, I'm going to use a -2. +2 and -2 cancel. I'm left with just r, and that is r is greater than, sorry, I almost wrote an equal sign like I told you not to do. -5 and a -7. If you think about these in my battle boxes, we have 5 and we have 2. They're both in the negative box. I know my answer is negative. 5 plus 2 is 7. So my answer is -7. I filmed just a couple answers so I know which direction I'm going. So here's my solution. R is greater than -7, so let's go ahead and graph it. It's a just greater than symbol, so it's an open circle, and if it's greater than, it goes to the right. And let's check our answer. What is a number that's bigger than -7? 0 works. 0 is bigger than any negative number. So let's plug it back in. 0 plus 2 is greater than -5. Well, anything plus 0 is just itself. That's the identity property. So is 2 greater than -5? Sure is. So that means my solution is correct. All right, so let's look at our next two examples. So in this one, we have t is being divided by 14. So again, I'm just going to divide both sides of my equation. To undo division, I'm going to multiply, and we use these parentheses to show multiplication. So I'm going to multiply by the number that I'm dividing by, which is 14. 14 divided by 14 is just 1, so we have just t. Don't forget you're using an inequality symbol. I didn't divide or multiply by a negative, so my sign stays the same. And then I'm going to multiply 6 times 14, which is 84. And if I think of my integer man, I have a negative times a positive. So what's left is a negative, so I know my answer is negative. So my solution says that t is greater than or equal to -84. Okay, when you're graphing, you don't have to write all the numbers. You just have to write enough that I can see that you know which direction it's going in. So t is greater than or equal to, which means it's a solid, since it could be equal to -84. And it's greater than, so it goes to the right. Now let's think of a number that's bigger than 84. Well, 0 works. 0 is greater than or equal to 84, -84, sorry. So I'm going to use 0. Let's plug in 0 divided into 14 groups. Is it greater than or equal to -6? Well, 0 divided by anything is just 0, because you can't divide nothing. So is 0 greater than -6? It sure is, so that means my check step works. So this is exactly the same stuff that you were doing when you did one-step equations before. The only difference is that inequality symbol in the middle. And if it helps, take a highlighter and highlight it down to divide your problem, and then that way you remember that that has to stay. So in this case, I have a -5 times p is less than -95. To solve this, I have to use the inverse operation, which is division. I'm dividing by -5, divide by -5. Ooh, I'm dividing by a -5, so I have to flip my sign. So instead of less than, it's now going to be greater than. These cancel, and I'm left with just p. P is greater than, and 95 divided by 5 is 19. And then think of your integer guy. A negative divided by a negative is a positive, so it just stays as positive 19. Okay, and it's just greater than, so I'm going to leave it as that, and it goes to the right. So now to check my solution, what is a number that's greater than 19? I'm going to use 20 because 20 is an easy number. So 20 is greater than 19. So I'm going to use 20, plug it back in. -5 times 20 is that less than negative 95? A negative times a positive is a negative. 5 times 20 is 100. Is negative 100 less than negative 95? The answer is actually yes. It looks like it's bigger, but remember with negative numbers, the more in debt you are, the less you have. So with a negative 95, and then we keep going, 96, 97, 98, 99, this is negative 100 over here. And the farther left you go, the less you have. So this is actually true. So that's the first page of your notes. We are going to go through a couple more examples. I'm not going to go through all of these on the back. I just want to keep going over how to do this so it's fresh in your head when you go to do your homework on Edmodo. So if you look at this example, number 1 on the back, that has a negative sign, and I'm going to attach that negative sign to that 12. So when I undo this, I'm actually going to be multiplying, because it's division right now, I'm going to be multiplying by a negative 12. Ooh, what's that rule again? If you multiply by a negative 12, then I have to flip, flip, flip. So I'm going to draw this down, and I'm actually going to go ahead and do that so I don't forget, because most of the times when you're solving inequalities, this is the mistake you're going to make. You're going to forget to flip your sign, or you're going to make a small error with your calculations with the integers, but this is probably the biggest mistake that everybody makes. So if I'm multiplying by negative 12, these cancel, and I'm left with just x here. 5 times 12 is 60. And if I have a negative times a negative, that equals a positive, so I just leave it at 60. So when I graph this, x is less than or equal to, so it's a solid circle, but the smaller side is pointing towards the x, so it's less, which means it goes to the left. Left is to less is to the left. All right. So we're looking for something that is less than 60. Let's use 0, because 0 is less than 60. So we're going to plug in 0. Divided by negative 12. Is that greater than or equal to negative 5? Well, 0 divided by negative 12 is just 0. Is 0 bigger than negative 5? It sure is. Okay. So if we look at the next one, we've done some multiplication and division. Let's look at what's being done here. We have x minus 3 is greater than 12. So to undo subtraction, I'm not multiplying or dividing, so I cannot automatically bring down my sign. I'm going to add to undo the subtraction. Whatever I do to one side, I must do to the other. These cancel, and I'm left with just x is greater than 12 plus 3 is 15. So x, let me bring my x down so it looks like it's down here with the problem. X is greater than 15. Here's my 15. X is just greater than, so it's an open circle. And since it's greater than, it's going away from 15 and getting bigger. Okay. So let's scoot on down to number 3. Number 3, it looks a little bit different, but it's the same exact process for solving. It just has the 16 and the g plus 3 are switched, but you're still solving it the exact same. So bring down your sign, because I'm just adding and subtracting to undo this, so I'm not going to change my sign at all. If I have a positive 3, I'm going to subtract 3 on both sides. Bring down your g. 16 minus 3 is 13. So this says g is less than 13. So here's 13. It's surrounded by 12 and 14. It's just a greater than symbol, less than symbol. And remember, we read from the variable, so we got to read it from the g side. G is smaller than 13, or g is less than 13. Because if you read it as 13 is greater than g, that's going to get you confused. And you're going to think, oh, I got to go higher. But that's saying 13 is the biggest. 13 is the most you can have. G, or all your other answers, are less than 13. If you can think of it that way, that's fine. Go ahead and go for it that way. Look at number 4. Number 4, we have negative 3 times x is less than or equal to negative 18. To solve this, I have to divide, and I'm dividing by a negative. So if I'm dividing by negative 3, then I have to flip my sign. So I'm going to flip that before I forget. Divide by negative 3 here, divide by negative 3 on the right. These cancel and I'm left with x. 18 divided by 3 is a negative 6. So we're going to put negative 6 here. Negative, oops, I did that backwards. That should be negative 7. And this is negative 5. It is an equal to, so it's a solid circle, and it says x is greater than negative 6, so I'm going to the right because they're bigger. My solution is bigger. I'm not checking these. You should be checking each one, but I'm not checking these just for the sake of time. Okay, one last one I want to go over with you, and then I'm going to review the notes, and then we're going to be done. So look at number 6. We're going to skip number 2. Go ahead and try number 2 if you want to. I'm not going to solve it here, but I'll put it in the Edmodo quiz. So with this one, we're multiplying by 1/2. So remember I said sometimes you'll use the multiplicative inverse. So when we use the multiplicative inverse, we're going to take this 1/2 and flip it upside down. We're going to multiply by 2 over 1. I'm not multiplying by a negative, so I can leave my sign the way it is. These cancel, and I'm left with just x on this side. Because 2 times 1 is 2, and 1 times 2 is 2, so I get 2 over 2, which is just 1. Now I have 20 over 1 times 2 over 1. 20 times 2 is 40, and they're both over 1, so my answer is just 40. So my solution is 40. We have 41 on this side, and we have 39 on this side. This says x is greater than or equal to 40, so it's a solid circle, and it goes to the right since it's greater than. Okay. Last thing we're going to do before I let you guys go to do your Edmodo quiz is to go over these notes. So as a review, when you're solving inequalities, you solve them using the inverse operation. If you don't remember the inverse operations, go back to your equation notes. They're all in there. Like you would, and you're solving just like an equation. If you multiply or divide by a negative, it's important that you know it has to be a negative number, then you must flip. So think it goes like this. So if it was this way, it goes to this. Or if it was this way, it goes to this. So that's all you're doing is changing the direction of your inequality sign. And then to check your answer, you plug in a number that makes the inequality true. So you're finding a number that makes that statement a true statement. That is all we have. Go ahead and try to solve number 5 because we didn't solve that in our notes. I want you to try to solve number 5, and it will be one of our questions on Edmodo.